Hi everyone, I continue on the lesson. So I'm going to do a topic 12, which is density and conversion. And as I mentioned many times, we focus on conversion and math parts. Okay, so density is the mass per unit of volume, and you heard it many times. Okay, so how much mass we have per unit of volume, that would be the density. So from earlier in conversion topic 9, we had something about pure water, that 1 gram of water was like 1 milliliter, exactly like 1 milliliter of water and 1 centimeter cube, which was a bridge that we talked about before. So this is like, so 1 gram per 1 milliliter. So that can be density of pure water. Okay, so now we can just do one example very fast. We can start examples because we just did conversion before, so these are conversion as well. What is the volume of 1 mole of pure water? Here I have to say pure water because that was for pure water, the formula. Okay, so I have 1 mole of water, pure water, and I want to go to uh, so volume, milliliter of water. Okay, so milliliter. So okay, so how can I go directly? I know I have something between mole and weight, so I can go from mole to gram for water, and then from gram to mole. How do I do that? So this one I do with molar mass, and this one I do with density. So I changed the color but didn't work. Okay, so molar mass here and density, and we need to know what is molar mass, which is given in red part. Okay, so here I have 1 mole, here I have 1 mole of water. Okay, multiple, I have 1 mole. I want to cancel mole and I want to bring gram. Okay, so 1 mole is 18.02 gram. Okay, so grams, I can just write G here, and it depends on what do I have. Here I have mole, I want to cancel mole and I want to bring gram because I want to go to gram, so I write gram up. Okay, so and then it is gram of water, pure water, and then multiple, and now I want to go to milliliters. So 1 gram of pure water is the same as 1 milliliter of water. Okay, so now I can cancel mole with mole, I can cancel gram with gram, and what is left is this one. So 1, this one, and this one, and this one, and this one, and the answer is 18.02 milliliter of pure water. Okay, so 1 mole, because okay, 1 mole is this many gram, and because this many gram is the same as this many milliliters, so it didn't change, the number is the same. Okay, so each chemical will have a different density, so that you can search, you can remember them, but it will be given to you. So you can know density is the directly varies, so like direct variation, like in topic 8. So directly varies with pressure and inversely with temperature. So if pressure goes up, then it goes up, and if temperature goes up, it goes down, because that's indirect. Okay, so we just so we just don't so let me see, the decreases with, yeah, so we don't go to those topics. Okay, so we just accept that we have density for different substance, and so we have the density, and then we use it in our conversion questions. Okay, so here, so how do we use this, how do we do these questions? Okay, so these questions, the same as this table here, which was similarly given to you before. So maybe I give you gram and I want to so ask for example, I give you mole and I want volume, the same as pure water, which I did. So yes, I know I can go from mole to gram, that's the lesson before, molar mass. I can go from gram to volume, that's density, the lesson now. And I can go from mole to maybe volume because I can do the bridge. So here I can go, from this one to this one. Here I can go from this one to this one, opposite, vice versa. Also I can go from, for example, mole to volume or volume to mole. So I can do the bridge. So the same as what I did now for pure water. Okay, so I can do more examples here. So how about this question? In a chemical reaction that requires this many gram of ethanol, how many liter are used? Okay, so I want to go from 116 gram of ethanol. Okay, I want to go to number of liter. Okay, so how can I do that? Okay, so gram to liter. So I look at my I look at the red part and I see I have something between gram and milliliter. So I can go from gram to milliliter using density. And now I can go from milliliter to liter using conversion factor. Okay, so yes, so here it's 116 gram ethanol multiple. So I want to cancel gram, so it's 0.789 gram, okay, ethanol 1 milliliter. I know there you see this gram per milliliter, but here I want to cancel gram, so I need to write it down. So it depends on the question. Maybe I have to write gram per milliliter, or maybe gram down, milliliter up. But still it's the same. Okay, so multiple. Then 1 milliliter is 10 power minus 3 liter. Okay, and then I'm done. Okay, so now I can cancel gram of ethanol with gram of ethanol. I can cancel milliliter of ethanol. Okay, the milliliter of ethanol here, yeah, ethanol here, and this ethanol, oops, and this, that here. Okay, so how many milliliter? Okay, so that's here, and then I can cancel. So I can cancel this one with this one. Oops, I press, it doesn't work. Okay, so this one, and then what is left is this one, and this one, and this one, and this one, and this one. Okay, so what is the answer here? So the answer here is 0.1470. Okay, so I have three significant digits. Because all of them are not exact, so they are approximate. So maybe I can give you 3 digits in density, or more digits in density, 4 or 5. Okay, so and those other numbers are exact numbers. Okay, so I underline that, I check that it is almost 0.147 liter of ethanol. Okay, so how many moles are in this milliliter of mercury? Okay, so I want to go from 234 milliliter of mercury to mole. How can I do that? Okay, from milliliter I can go to gram using density. Oops. So density, and from here I can go to here to mole using molar mass. Okay, so I need to have those information which are given to me in red. Okay, so 234 milliliter of mercury multiple. Yeah. Okay, so Mercury, so this milliliter of mercury here, and then I want to cancel milliliter of mercury. Where is it? So milliliter of mercury, yes. So 1 milliliter of mercury is 13.590 gram of mercury, gram. And okay, so gram, I can use Hg for mercury. So here, yes, okay, so milliliter and that, okay, yes, I can use that. So this one, multiple. And then I want to cancel grams, so I need to have the molar mass here, and then I write 1 mole. Okay, so now I can cancel milliliter of mercury with milliliter of mercury. I can cancel gram and gram, and then mole is left. Okay, so 1 mole, this number, this number, this number, and this number. And I have 3 significant digit, I have 5 significant digit, I have 4 significant digit, which I can round to 3 significant digit. Okay, so then the answer is this number. Okay, so the answer is 4.187. okay, and I underline that, check that, it is almost 4.19 mole of mercury. Okay, yeah, let's say we don't know what is the symbol, so we can use mercury just as a word. Okay, so doesn't matter. Here, the next question, there was a task. Okay, you can give it a pause and just read the question. There was a task of just giving pure gold to a goldsmith and ask for a crown, like for a temple. The crown is here, you can see it. They heard that the goldsmith is not an honest person, so he removes some part of gold and add some silver. Gold is just more expensive, so they just want to have it, just he or she want to have it for himself, and then they want to just add silver, and then so then they make the crown, and then just the task will be done. And so they wanted to really discover what they have to do in this case in order to find out this, if the goldsmith did this or not. Okay, so somebody said, that is explained here, if we have water here and we just put the crown inside, so I didn't draw it very well. So if we put the crown inside, so some water will be removed from the container. This water, if we calculate volume of this water, will be volume of the crown. So if we can find out volume of the crown, for example, if we ask for 500 gram, for example, and we believe it's pure gold, we can use density of gold to just go to how much volume we do have, and then we can just calculate the volume of the gold if we believe it's gold, and then also we can see volume of the water which is removed from the container when we put the crown inside, and we can see if it's really gold, because we calculate based on density of gold, and also we see the water which was the volume of water which was uh, just just displaced from the container when we put the crown inside, and we can see if it's equal. If it's not equal, then we can. So then now here we have to consider how about if part of it is silver, if all of it is gold, and if part of it is gold and part of it is silver. So we can calculate the volume and see what is the difference in this case, and then we can just come up to an idea to see if we calculate volume of the water which displaced from the container when we put the crown inside, can we say it's all gold or no, part is silver? Okay, so let's consider this. If we have 500 pure gold, what will be the volume? Okay, so I have a crown which is 500 pure gold. Okay, so pure gold here. Okay, so here for pure gold I can use AU. Okay, or I can say just gold. Okay, so I have, for example, if I have 500 gram pure gold, means I have 500 gram of AU multiple. Okay, so I want to see what is the volume. So I have to use density. Okay, so where is gold? So 19.29 gram is per 1 centimeter cube. Doesn't matter if I have centimeter cube, I know 1 centimeter cube is 1 milliliter. I can do that. Okay, so now I can cancel gram of this with gram of this. I can cancel 1 centimeter cube of this with 1 centimeter cube of this, and then I am left with milliliter. So we can consider this, we can consider this, and this, and this, and this. What is the answer? The answer is 25.92, which is almost 25.9 milliliter pure gold. How about if it's not pure gold? So we just assume, for example, 75% gold, 25% silver. Okay, silver Ag. Okay, so yeah, here, so this one I have to change to that. Yeah, okay, so 500 gram, okay, the crown multiple 75% is, so 75% is gold. So out of 100 gram of crown, 75% is gold. Okay, this is we assume. Okay, so first we assume if it is 500 gram gold, and we find out the volume. Now we assume if it is partly gold, partly silver. So how much? Okay, 75 and 25. Okay, so we can do any other percentage. Okay, so 75, and so here, then I have 19.29 gram of AU 1 centimeter cube, and then 1 centimeter cube of AU 1 milliliter of AU, and then I can cancel this and this, this and this, this and this. Okay, So what is left here? This guy, and 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 this guy. Okay, so the answer is 19.44 this milliliter. I don't need to round it because I want to find out the 25% and then I want to add them and then I can decide. Okay, so 500 gram of crown. Now 25% gram is 25% gram is Ag, and this is 100 gram crown. I want to cancel and I want to find out for that. Multiple. What is the density of that? Density of this one is this many gram, 1 centimeter cube of Ag. Multiple. 1 centimeter cube of Ag, 1 milliliter of Ag. Now I can cancel. I can cancel this and that. I can cancel this and that. I can cancel this and that. What is left here? This one is left here, and this one, 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 and this one. So 11.916 milliliter. Then I can add these together. When I add these together, it is 19.440 plus 11.916. Yeah. Which is 31. That's 31.356 when I add them. Why I have to add? Because 75% is that, 25% is that, 100% is together. So I have to add them. So when I add them, then it is almost 31.4 milliliter. Let's compare these two numbers. This is what if I have just gold. This is the volume if I just have gold. And this is the volume if I have part gold and part silver. So I can put the crown in water. A part of the water just displaced from when I put the crown inside. I can measure that water in terms of the volume. Okay, so I can find out what is the volume of that water which is just displaced from the container. For example, if I put the crown inside, I can measure it. If the volume is more than 25.9, okay, I can say it's not all gold. It is partly silver, and the fact about the person, the goldsmith, is not just this is not just something that we assume. So yes, it happened. Okay. See, in the second case that we have gold and silver, the volume is higher. Okay, so the volume is higher. So here, look at this. So the volume, the volume is higher. So 31.4 is higher than 29 point, what's that? 25.9. 25.9. So here is just gold. Here is gold and silver. Okay, so I just guess. So 75 and 25%. I can change the percentage, and for all of them it will be more than 25.9. So the volume is higher. So this is our hint. When we receive the crown and we measure the level of water, okay, if we see the volume of the water is more than 25.9, then we can say yes, gold is being removed, and a silver is added, and the person wasn't really honest. Okay, so this is the use of that's a application and good example of just related to history, and also related to density here. Okay, that we can use. What else? So here I can continue to the next question. So the next question here. So maybe I can, so I have this question here, and yes, I can talk about it. And also I have this question, and then and then we'll be done. Let me see. Yes, then it will be practice and then we are done. Okay, so here I can stop and I can do just in the next video. Okay, so here I can say this is video number 1, and then I can continue in the next video to do example 3 and 4. Thank you so much. Bye.